In my last video, I was talking about how we have our 20 amino acids from our tissue and how they were transported to the liver in the form of alanine and glutamine, so it can be used in the liver to go through the urea cycle to convert that nitrogen to urea so it can be eliminated. So in this video, what I'm going to be talking about is what happens when you have your substrates alanine and glutamine. What happens to them? How do they get converted to urea? So before we continue with this one, I have to tell you that there are two main substrates for the urea cycle. The first main substrate for urea cycle is going to be ammonia. And then the second one is going to be aspartate. So these are our ends goal. This is what we need to change our alanine and glutamine to. But the process is not really straightforward. So if we go back to remember how our amino acids can interconvert with each other using metabolites from the TCA and glycolysis, we can recall that pyruvate makes alanine. We know that alpha-ketoglutarate makes glutamate. And we know that OAA can make aspartate. So as usual, you have to know these metabolites and their conversions. So, like before, in order to transport nitrogens around, we need to have some sort of molecule of PLP and transferring them between metabolic products. So if we have an alanine and we want to transfer this nitrogen away, the alanine will become a pyruvate utilizing a PLP, and then it will transfer it to the middleman, which is going to be your glutamate. Which comes from alpha-ketoglutarate. Just a convention of how I usually organize this, I usually put everything on one column. Like for example, over here I put all my alpha-keto acids. And I always put my amino acids on the same exact column so that I don't get confused of where these nitrogens are going. All right, so we know that reaction already, and but glutamate isn't one of those amino acids that we need to use for urea cycle. It's going to be aspartate and ammonia, but we also know that a metabolic product that we have, OAA, can be converted to aspartate. So I'm going to change that color because that's our main end product. And then this is transferred by a PLP. So that's not too bad. That's the first product that we have. But there's another way in which glutamate, if you recall from the first lecture that we had, glutamate can lose an ammonia to become back into alpha-ketoglutarate. I'll just put on that. Yeah, you know what I mean. All right, so over here, this enzyme over here is going to be glutamate dehydrogenase. So alanine is able to make NH4, ammonia, and aspartate through the same exact reactions that I talked about in the first one, except the goal is different. In the first case, the goal is to make alanine and glutamine, and then using glutamate as your intermediate. In these transfer reactions, our goal is nitrogen in the form of ammonia and aspartate. For glutamine, it is a very similar process, but glutamine first becomes a glutamate. In order to do this, they need to use this enzyme called glutamase. Do you remember the reverse reaction before? It's glutamate synthase. Glutamine synthase. You don't need to know the glutamine synthase for this one. Just be aware that it's there. So when glutaminase occurs, you have an ammonia ion that is released. But wait, there's more. Okay, let me just tell you. This is 2 nitrogens, and then now it has 1 nitrogen. There's more because this glutamine over here still has 1 nitrogen. And since glutamine could interconvert with any amino acid, and your goal is aspartate, it makes sense that this glutamate can perform the same exact reaction as in this reaction. So this can also change to alpha ketoglutarate via the glutamate dehydrogenase. And then this can create a nitrogen. And finally, there's one more with this glutamine. This glutamate can do the same exact reaction as this one over here. And that would be the glutamates interconverting to alpha ketoglutarate, giving it up to aspartate. From your OA. And of course this is a PLP reaction, and then this gives you, this is a transfer of nitrogen. So those are your end products. So this nitrogen over here, this aspartate over here, this nitrogen coming from here, this nitrogen coming from here, and this nitrogen coming from here. You'll know that alanine can become some sort of aspartate or ammonia, and you know that glutamine can become some sort of ammonia or aspartate. So now we have to send this into the urea cycle, and then that's what I'm going to do on my next video.